Welcome, Calculus AB. This is lesson 5.5, U Substitution. Let's begin. So, how would you integrate this thing right here? So, like if I did an integral like this. And if you're thinking of our power rule and you just tried with just the power rules we've learned before, you say, oh, the third power, right? So you go just 1 plus 5x to the fourth power and divide by new exponent. And you say, yeah, that's my answer, right? Well, and so my answer is 1 plus 5x to the fourth plus c. Well, let's derive what we just got and see if this actually goes back to that. So if we tried to derive this function, the c goes away because that's 0. So derivative of 1 plus 5x to the fourth will be 4 times 1 plus 5x to the third times the chain rule. Derivative of the inside is 5. That's not what we have. We don't have that 5. So there's a little bit something extra we have to do when we're integrating something funky like this. This almost looks like stuff we've done before with power rule, but the problem is, like, it's not just power rule, there's this thing inside. It's not just an x to the third power, it's this thing to a third power. So we got to do something else, and that something else is basically a reverse chain rule, which we're going to call U substitution. So to do this reverse chain rule thing, you basically figure out you're going to substitute u, which for part of this expression, and then that turns the expression to something that we recognize and can integrate. Why do we pick u? I don't know, we just pick a letter. That's just the letter used. So we're going to take this thing in here, and we're going to say u equals 1 plus 5x, and then so it's u cubed, and then you can integrate this. But there's a few more steps to that. But that's the heart of this. We're going to take something complicated in here, substitute a variable, u, to make it something that we can actually integrate. So what are the steps for this? So how it works is you're going to set u to some part of the expression. You're going to find your du. And so you set a u equal to something. And then you got to find your du is going to equal to something. That's just deriving it. And then you're going to substitute in that u and du, do your integrating, put the x's back in, you're done. So let's go, let me make sure what I was planning to do. Yeah. So let's do the steps. I'm going to figure out a u first. So I'm going to say my u is going to be that thing inside, 1 plus 5x. So du is basically means the derivative of 1 plus 5x, which will be 5 times dx, okay? Because we're deriving an x. Just do that. So we're going to substitute these things in. So I'm going to put this 1 plus 5x, we're going to put this as purple. And we're going to turn this thing into u. And then we got to have a 5 dx. The problem is I just have dx. I do not have a 5. So what I'm going to do is I'm going to put a 5 in there. When it's just numbers, you can do this. But it's like I'm multiplying by 5. But what I must also do is divide by 5 on the outside. These kind of cancel each other out because 5 over 5 is just 1. So now I can substitute this in for my du. F5 dx, and this thing is going to be my u, and then I still have this 4 here. So I'm going to rewrite this as 1/5 integral of 4 times u to the third power du. No more x's. That's what we want. And I don't like this 4 being in here. I'm actually going to put it the outside because it's just a coefficient. So 4/5 integral of u cubed du. And now this is something I can integrate. So I'm going to integrate u cubed, u to the third power, so it's going to be u to the fourth over 4, and still times the 4/5. Oh, no, we don't do that. Let me say plus c. The 4's can cancel out here. So I get 1 over 5 times u to the fourth plus c. And then I'm going to put the x's back in because we want it to be in x's at the end. So I'm going to say it's 1/5 times 1 plus 5x to the fourth plus c. So that's my actual integral. And if we want to go double check this, we can derive this function and verify that it goes back to this original. So I'm going to derive this function right here. So 1/5 times 1 plus 5x to the fourth plus c. So if we derived it right here, the plus c goes to 0. So it'll be 1/5 times chain rule here. It's going to times 4, 1 plus 5x to the third times the derivative of the inside 5. So when I do this, the 5's cancel out. So I'm left with 4, 1 plus 5x to the third, which is exactly what we started off. So verified my answer. All right, this is going to take a lot of practice of this till you get comfortable. So how do you figure out the U? I just kind of told you the U. So sometimes you have to guess a little bit, but the common things for the U's are like the thing that's inside the parentheses. So if you have like something inside like a parentheses to a large power, it's probably that something inside. Like in this case, this would be my U. Or it's whatever's under the square root. So in this case, it's probably this guy right here that's going to be my U. And it's probably under the square root, this whole thing, that's my U. So look for something common like under square roots or inside parentheses. That's probably your U. And sometimes you do have to do a little guessing. So let's just do an example. What's my U going to be in this case? Well, a good guess is probably this thing. So I'm going to say U equals 5x to the 5th plus 4. Derivative of U is going to be 25x to the 4th dx. And nice thing is I have a 25x to the 4th dx. So that's just my du, and this will be my u. So when you substitute in, you say u to the 4th du. I didn't even have to do any of that weird work. So integral is u to the 5th over 5 plus c, and my final answer will be 5x to the 5th, 5th plus 4, all that to the 5th power over 5 plus c. Sweet. Okay, I'll save more for later. Let's do this one. This would be my u, so I'm going to guess that's my u. 3x to the 5th plus 4. So my du is going to be 15x to the 4th dx. And I do have a 15x to the 4th dx, so these two parts combine to be my du. So the integral is square root of u du, which is integral of u to the 1/2 power du. If you anti-derive that, u to the 3/2 power times 2/3 plus c. So my final answer is 3x to the 5th plus 4 to the 3/2 power over 3 plus c. There you go. I don't want to do more examples. Sometimes you have to do something weird. This is not going to happen too much. I want to show it to you. So you need to rearrange the u equals to solve for x instead, because u sub just doesn't work cleanly. So here's an example. And this typically happens when like your u, this has got to be your u, but it doesn't clear the x's out here very easily. So let's say my u equals x minus 1, derivative du would be just dx, 1 times dx. And that'd be great. So this is my du, and this is u, but that doesn't get rid of this x here. Well, I could rearrange this equation and say x equals u plus 1. Add 1 to both sides. So I'm going to say this thing is going to be u plus 1. So you substitute in, you get u plus 1 times square root of u du. So I'm going to actually distribute that square root of u, and that's the same thing as u to the 1/2 power. That's like u to the 1. So it's the integral of u to the 3/2 power plus u to the 1/2 power du. There. Now I can actually integrate this. I'm going to integrate it up here. So it becomes u to the 5/2 power times 2/5 plus u to the 3/2 power times 2/3 plus c. And sub in the u, going back to the very beginning. So it'll be 2 times x minus 1 to the 5/2 over 5 plus 2 times x minus 1 to the 3/2 over 3 plus c. So that's like the weird one. Doesn't happen too much. All right, that's it.